Hello, and thank you for joining Session 1 of the Higher Education Local Admin Certification. My name is Jennifer Kentner, and I'm the Education and Outreach Coordinator for the Ohio Facilities Construction Commission. In this session, we will be covering identifying project requirements and selecting delivery method.
This session is identifying project requirements, talking about master planning. My name is Lane Bucher, and I'm a program manager with the Ohio Facilities Construction Commission. So we are going to cover the funding cycle for state capital funds. We are going to cover what's involved in requesting capital from the controlling board and from the legislature. We'll talk about the stages of master planning, including a facility assessment, any demographic studies that might be necessary to study the area your institution is located and its taxing district, if applicable. Talk about how to incorporate your strategic plan into that master planning process. And then we'll talk about the controlling board briefly, and then we'll also cover the reappropriation cycle as well. So project scope for new construction, you're going to be looking at the program elements and square footage of the project, any site and utility requirements needed to bring to a new site if you're developing a new site, or where to get utilities if you're repurposing a site or building on your existing campus. And then what are the goals and expected outcomes for that project? What is it going to help you achieve in your strategic plan to build a new building? And then renovation projects cover the items in new construction, but you're also going to identify the areas of existing buildings and systems that they will affect. So this can have some additional costs because we don't always understand what the current systems might be. They may be buried in a wall or in a shaft, and so it takes some time to get to know a structure. So the project budget needs to include the cost for construction, which is typically broken down into two major categories: development of the site and construction of the basic building, including mechanical, electrical systems, plumbing, and so forth. There might be some technology that gets incorporated, and that may be part of your construction budget, or it might be a separate budget. For professional design services, those services provided by an architect or engineer or other consultants. We break our budget down into basic services and additional services. Basic services include those architectural and engineering services necessary to develop the main building. Additional services may include those costs for furniture, fixtures, and equipment, interior design, landscape design, things like that, landscape architecture. And then we also have reimbursable expenses, which we typically include things like plan approval fees, if we're asking the AE to include those in his contract. And then we reimburse those without any markup based on the invoices that they present to us. We may also ask them to advertise or pay the advertising costs, and there may be some document printing costs for things like stage submission reviews and things like that. I do want to mention that additional services, if you're dealing with a change order, we do allow the AE to present a percentage for marking up their additional services consultants, and that is something we put into our contract. Other direct expenses that the owner might have are project administration or management fees. If you are hiring an owner's representative, if you are hiring OFCC to manage the project for you, or if you're maybe even doing a construction manager as advisor type project, and we frequently saw that in the multiple prime days. Have seen that less frequently, more recently. Also, the owner's contingency is a very important part of the funding. We have recommendations in our manual on what the appropriate level of contingency is as a percentage of the construction cost. And the controlling board actually has in their section of the revised code a requirement that any capital release for a construction project must include a contingency fund. There also may be furniture and fixed equipment costs, cost for technology, and if the project is large enough, the percent for arts funding might apply. So this is for larger projects that usually in new construction, you may have to dedicate 1% of the construction cost to a piece of art that is developed in conjunction with the Ohio Arts Council. So in the project schedule, we allow time to procure professional services. The manual has a timeline for that. It takes some time. We need to allow the AE's time to review the RFQ and respond to it. We have a rule in our section of the administrative code that requires at least 14 days advertising on our website before we can accept statements of qualifications. It may be prudent to extend that to try to attract more proposers. The design stages we go through, we start with program verification, shown here as PV, schematic design, design development, construction documents. If it's a CM at risk or design build project, there may be a GMP negotiation stage. If it's a design bid build project, it might be a bid and award stage that is kind of in the design stages. And then we've got that covered under bidding and buyout. Buyout would be in a CM at risk or design build contract where the CM or design builder is procuring the services of subcontractors as well as getting suppliers of material and equipment to provide them pricing so that they can buy out the project. The contract approval process, if it needs to go to the controlling board, which it usually does if state funds are involved. There may be some times when you're using purely local money and it may not need to go to the controlling board, but it may need to go to your board of trustees. And then the construction phase, which is typically the longest phase, begins with a notice to proceed. And in the project schedule, there will be a date for substantial completion. And the time between those two milestones is known as the contract time. And then CCC is a certification of contract completion. And this can be certified as partial completion or final completion. So you may have some building standards or project quality characteristics that you are trying to achieve as a standard for your campus or for your institution. Many larger universities have institution-specific building design standards. They may have to adhere to your policies and procedures. Things like harassment and smoking and tobacco use, parking. Do they need to pay for parking for their staff to park? Do they need to park somewhere else and get bussed in? All of these things are in the category of your institution policies and procedures. If you received a federal grant or a grant from another agency or source, there may be some requirements attached to that grant. There may be some clauses or terms from the federal acquisition regulation that need to be followed, and sometimes those FAR terms, as we call them, need to be incorporated into the contract itself, or they can be implemented through supplementary conditions in a construction contract or special terms and conditions in an architect-engineer agreement. OFCC has a number of policies and procedures, and these are articulated in the contract documents that we produce. And if you're a state university or a state community college, those are required for you to use. And if you're a technical college district or a community college district, the Attorney General would like to see you use our contract documents, and it helps them know that the terms and conditions are consistent across the state's construction program. The Ohio Building Code is a necessary part of any construction project. It typically applies to most projects unless they're agricultural in nature or maybe military in nature. So most state property plan approval goes through the Ohio Department of Commerce, Division of Industrial Compliance, Bureau of Code Compliance. If your college is owned by your institution itself, you may be subject to local codes. And as far as zoning codes go, we try to comply, but there is precedent that if push comes to shove or it's a financial hardship, we can get relief. There may be other codes that apply. The Ohio EPA has regulations as far as stormwater water quality. And if you disturb 1 acre of land or more, you're going to need an EPA stormwater permit. LEED may be a goal of your institution, the leadership in energy and environmental design, or you may be pursuing Green Globes or WELL or living building certifications. Just depends under what constraints you put yourself. But others, like the Ohio EPA, are not voluntary. They are mandatory, as well as the building code. So it's very important to document the project requirements. And if you are going for LEED, there's another step to that. But we start with a program of requirements, or a POR. And what this does is it breaks down the building into the spaces that are necessary, classroom sizes, conference room sizes, how many people are going to occupy each of those spaces, what services need to be brought to those spaces, electrical outlets, if there are special outlets. I know in one POR I was associated with, we had a client that had a centrifuge, and so we knew that we needed a 220 circuit in the lab equipment area. And what we failed to do was determine whether that needed to be a 20 amp or 30 amp breaker and circuit for that centrifuge, and it turned out to be 30 amps, so we had a change order. So always try to document the requirements of your services to the greatest degree possible. And program of requirements is typically done before you start drawing any adjacencies or creating any designs. The design stages have a review process, and we ask that the architect engineer submit those for review by the owner and by our team at schematic design at the end of design development. And we also ask for them to submit multiple times during construction documents, usually at 50% complete CDs, and then usually at 85 or 90% CDs, and then once again before we accept it for bidding. We also require that they obtain plan approval from the Department of Commerce before we bid the project. We have a document called Minimum Stage Submission Requirements, and it outlines all of the things that are required by either the architect engineer agreement or the building code or other required documents and requirements. So we do have a design service acceptance form that we ask the owner to sign to indicate that they've reviewed the phase submission and accept it. And then construction documents or contract documents typically are produced through each of those phases, and they include specifications and drawings. And they get greater detail as we move through those stages. For instance, specifications may be an outline spec at the design development stage, and then there'll be full-blown specifications in construction documents. Similarly, our minimum stage submission requirements have the drawings that are required at each of those stages. And for schematic design, it might be simple as a plan and a site plan. But we'll also ask them for massing studies and things like that. In design development, we are asking for more detail. We're asking for elevations and sections. And then construction documents, we're asking for all of the schedules and notes and dimensions that are required to construct the facility. So this concludes the master planning portion of the training. In this area, we also have modules on project priority, type of project, small projects, the local administration request process. If you have any questions, my contact information is on the screen. Once again, this is Lane Bucher, and thank you for your attention. This module is identifying project priority. And once again, I'm Lane Bucher, a program manager with OFCC. In this module, we're going to cover emergencies, the exigency concept, projects that are considered urgent, projects that are normal, and then we'll also talk a little bit about phased projects. So for emergencies, the revised code section 153.71B talks about waiving the qualifications-based selection process for any project determined in writing to be an emergency that requires immediate action. This can also include a project requiring multiple architects and engineers as part of a large program that is an emergency. An exigency is a slightly difficult concept to wrap your head around. Revised Code Section 123.10 defines a public exigency as an obstruction that occurs in any of the public works of the state that materially impacts or impairs its immediate use or places in jeopardy property adjacent to it. A public exigency is declared by the OFCC Executive Director upon the request of a state institution or agency. So if your institution has an urgent need or an exigency that you think rises to the level of 123.10, you would make a request upon our executive director, and then they would make a declaration, and that declaration identifies the specific danger, the scope of work, and the limit of the amount of that exigency. Once that declaration is issued, OFCC sends notice to the Ohio Office of Budget and Management and the Controlling Board. So it goes to the president and all the members of the Controlling Board. And what that declaration does is it waives the procurement requirements for architects and engineers and also contractors. So it allows an agency or OFCC on their behalf or an institution of higher education to contract with those folks without getting approval by the Controlling Board ahead of time. However, often we will see folks go back to the Controlling Board to get funds released for that. And in order to get the purchase orders to square away in the system, sometimes it requires that to be identified as a waiver of competitive selection. But that exigency does give you the ability to contract and get started. An urgent project is one where there's a need for immediate attention to eliminate or postpone a potential emergency or exigency based on the fact that there's an anticipated risk or danger if it's not addressed. There's defined and continued deterioration if nothing is done. There's potential for unusual cost or services if it's not addressed. And there's a high demand for the project's use and a dire need for additional space or facilities. So this is something that doesn't quite rise to the level of an exigency or an emergency, but is still important nonetheless. Normal projects are addressed in Chapter 153 of the Revised Code. There's a defined project via capital needs assessment. A budget is established and submitted and approved by the legislature for the agency through the capital appropriation process. This is a biennial cycle, so it happens every 2 years, and typically it starts with OBM issuing guidance for an upcoming capital bill. Capital budgets are approved in even numbered years, and operating budgets are approved in odd numbered years. Every 2 years, an agency or institution will submit their budget and their 5-year plan or 6-year plan, maybe. That talks about what they want this year and what they're anticipating needing for the subsequent 2 biennia. Replacements and renovations and construction needs to be in accordance with the agency plan and goals. And any upgrades to existing facility for efficiency or cost control, you might need some money to put in a new boiler that's more efficient or some other capital improvement that improves the efficiency of the building. And then phase projects. Oftentimes we get involved in projects that are funded over more than one biennium. And so the first project needs to occur before the second project. So project A might be in the current biennium or in the next biennium, and then project B would be in the biennium that occurs 2 years later. Those funds are then available over multiple biennium. Also might include partial or phased occupancy. And there's a need oftentimes to maintain services during construction of that subsequent phase. Sometimes there might be a need to swing the program that's housed by that facility into another space for a period of time. And you always need to consider moving costs if you're swinging out and swinging back in or going from one building to another. I worked on a project at a major university where we built a 4-story building really close to an existing building. And then we demolished that existing building, leaving an addition that was added somewhat later. And then we built a cap building that connected the 4-story building with the addition for the previous building that was demolished. To provide vertical circulation, restrooms, and other program elements that were not in the addition. So we made it a complete building by putting on what we called a cap. But that was an interesting project to see and, to do demos so close to something we had just constructed. And we were very concerned about the demolition falling into our new building. It actually ended up causing some damage to the addition. So we had to fix that and build the cap. All right, so that concludes this module. We've covered master planning in our previous module, and upcoming modules include type of projects, small projects, and the local administration request process. Once again, I'm Lane Bucher with OFCC. If you have any questions, feel free to reach out to me. Thank you. The topic for this presentation is identifying the type of project. My name's Lane Bucher, and I'm a program manager at OFCC. The outline of this slide deck is going to talk about maintenance and repairs and construction and renovation. And these are the 2 project types that we will be dealing with, and we'll talk about how they're identified. So maintenance and repairs include routine maintenance or repair of any existing public facility. Repairs typically do not require professional design services or plan approval by the Department of Commerce. They typically do not affect the public health or general safety. So for a maintenance project, you might be sealing your asphalt pavement. You may be repairing or patching the asphalt. You're doing pothole repair. But if you're doing construction, then you're looking at replacing the entire parking lot. You may be grinding and laying down a new wearing course on that lot. So maintenance is something small and isolated, and construction is a major upgrade. So for construction renovation, we talk about the process of building, erecting, altering, improving, or demolishing any public infrastructure. And that is the definition adapted from the revised code. The revised code doesn't have a definitive definition for construction, but we take this from the requirements of Chapter 153. And when Chapter 153 is required to be followed, and 153 deals with construction and renovation. Construction renovation typically exceeds 200,000, or if it involves professional design services or requires plan approval from the Department of Commerce. Examples of these would be replacement of an entire roof, any intervention in an HVAC system or lighting system upgrade, or utility improvements. So it doesn't have to be major when you're dealing with the systems of a facility. If you're doing more than just monitoring that system or replacing a valve in that system or replacing a pump, if you're installing a new boiler, if you're installing a new chiller, if you're installing rooftop units, even if they are like kind, you may need a building permit, which would take it into the classification of construction. So we have a number of procurement options for services in construction. Professional design services are acquired through the qualifications-based selection process, which we abbreviate QBS. This involves publishing a request for qualifications, or RFQ. We also have a pre-qualified consultant list, and a number of the universities and colleges may also have a list of consultants that they use on an ongoing basis. That kind of short circuits the QBS process and allows you to perform some of those functions in advance of when a project is identified, and then complete those activities once you have a project for that consultant to work on. You ask them for a fee and technical proposal and get moving on the project. For construction, we have the public bidding process, general contracting, and multiple prime, and that is considered a competitive bid by the controlling board. We also have for CM at risk and design build something called the best value selection process, which is a combination of qualifications and price. DAS, Department of Administrative Services, has a requisite procurement process that requires state agencies to submit a purchase request to them to allow the first or second requisite procurement programs like Ohio Penal Industries or another first or second requisite procurement program to determine the request does not require a review. OFCC is a second requisite procurement program, and we look at things that are related to building systems to determine whether it's subject to Chapter 153 or not. As I understand it, universities and colleges do not have to use this, but state agencies do. And I mentioned Ohio Penal Industries and community rehabilitation programs are first requisite procurement programs. And then second requisite procurement programs are things like the Business Enterprise Program at the Opportunities for Ohioans with Disabilities Agency, Office of Information Technology through DAS, Office of State Printing and Mail Services at DAS, and the Pharmacy Services at the Department of Mental Health and Addiction Services. OFCC, as I mentioned, is also a second requisite program. And then any other program within or administered by a state agency that requires by law purchases to be made by or with the approval of the state agency. When OFCC reviews the purchase request, we determine whether the request is for design or construction services, and if the size of the request exceeds 200,000. If the request is for construction services exceeding 200,000 or for design services of any value, OFCC will indicate the project is subject to Chapter 153 and must be administered either by OFCC or by the agency or institution through local administration authorized by OFCC. In a couple modules, we'll talk about local administration and the requirements for universities and colleges, what those thresholds are. So local administration request is we refer to as an LAR in Oaks. It uses form 70-01. It includes some agency or institution and project specific information and identifies the key project staff. Local administration certification, which is the purpose of this training, is applied through form 70-F70-02, and it also requires institution specific information, key project staff, including resumes, current and pending projects, and that's pretty much it. It is usually done once at the beginning of your certification, and then there's a requirement to reapply for certification every 2 years when a capital bill is passed. Other related training modules to this include master planning, type of project, small projects, and then the local admin request process. If you have any questions, feel free to contact me at the email on the screen. And that concludes this module. Thank you.
Hello, I'm Craig Weesey, Chief of Projects at the Ohio Facilities Construction Commission, and I will be covering the topic of selecting a project delivery method. I'll briefly describe the available methods and how well they apply to various types of capital projects. There are 4 different project delivery methods available to public authorities in Ohio: multiple prime, general contracting, construction manager at risk, and design build. Multiple prime, the only delivery method allowed prior to 2012, can be implemented with or without the use of construction manager as advisor. There are some similarities between these project delivery methods, as well as some key differentiators. Due to those differences, a particular delivery method may provide a better fit with the characteristics of a specific project. The diagram shown here illustrates the delivery methods in comparison to 4 broad project characteristics. At the center, each delivery method is represented by a circle, and its location to the other methods attempts to illustrate where that project delivery method fits in comparison to the project characteristics shown within each arrow. The project characteristics used for comparison purposes are project size, project complexity, schedule importance, and owner decisiveness. Each of these characteristics range from small to large or low to high. Multiple prime, abbreviated as MP in the diagram, is shown in the lower left quadrant, representing that this delivery method fits better for projects that are small in scale, low complexity, do not require fast execution of the work in regards to the schedule, and can better accommodate indecisive owners during the design phase. Examples of projects that may be a good fit for multiple prime are ones that cover limited scope in just 1 or 2 different trades, such as re-roofing a building with existing rooftop units that need to be temporarily relocated and reinstalled after the roofing is complete. The coordination between trades are limited, which reduces risk on the owner for holding separate contracts for each prime. General contracting, abbreviated GC in the diagram, is shown in the lower right quadrant of the diagram. When comparing this delivery method to the same project characteristics, the GC method can more easily adapt to larger scale projects with more complexity than multiple prime. Although there are many different project types that general contracting would be a good fit, the GC method follows a more traditional design, bid, build approach, which limits its ability to fast track projects with multiple packages or phases. Design build, abbreviated as DB, is in the upper left quadrant, representing that it is more applicable for fast track or schedule driven projects, while it requires a more decisive owner to make decisions timely. One classic example of design build is a parking deck that is simple in nature and repeatable for each floor. Design build in conjunction with design assist, which is an option for including specialty contractors in the design phase, can handle more complex projects with unique design features, such as a curtain wall. Finally, construction manager at risk, abbreviated as CMR in the diagram, is located in the upper right quadrant. This delivery method is ideal for large projects in scale, complexity, and schedule driven that are led by decisive owners. CM at risk is popular choice for large projects, while it is typically difficult to fit within small projects less than 10 million due to the pricing structure. In those cases, other delivery methods, such as general contracting, may be a better fit for small projects. The overlapping of these circles illustrates that there isn't a one-size-fits-all type of solution when choosing the best delivery method for a project. Multiple methods can work, and in fact, prior to 2012, multiple prime was the only allowed method for public construction in Ohio. So public owners made multiple prime work across all of these project characteristics. But now with the flexibility of alternate delivery methods, owners can choose which method fits best for their needs. Each project delivery method has its own mix of advantages and disadvantages, presenting different risk profiles for the public owner. It's important for the owners to understand their options and carefully select an appropriate delivery method that meets their needs. This concludes our training on project delivery method. Our related training modules will describe each of the 4 delivery methods in more detail. Thank you for attending this introductory session. Hello, I'm Craig Weesey, Chief of Projects at the Ohio Facilities Construction Commission, and I will be covering the topic of multiple prime delivery method. I will briefly describe the characteristics of the delivery method as well as its advantages and disadvantages. Multiple prime is one of 4 available project delivery methods to public authorities in Ohio. The others are general contracting, construction manager at risk, and design build. There are some similarities between these project delivery methods, as well as some key differentiators. Due to those differences, a particular delivery method may be a better fit for a particular project. The diagram shown here illustrates the delivery methods in comparison to the 4 broad project characteristics. At the center, each delivery method is represented by a circle, and its location to the other methods attempts to illustrate where that project delivery method fits in comparison to the project characteristics shown within each arrow. The project characteristics, for the purposes of comparison, are project size, project complexity, schedule importance, and owner decisiveness. Each of these characteristics range from small to large or low to high. Multiple prime, abbreviated as MP in the diagram, is shown in the lower left quadrant, representing that this delivery method fits better for projects that are small in scale, low complexity, do not require fast execution of the work in regards to the schedule, and can better accommodate indecisive owners during the design phase. We will review characteristics, advantages, and disadvantages to help explain why multiple prime is shown here on the diagram. The overlapping of these circles illustrates that there isn't a one-size-fits-all type of solution when choosing the best delivery method for a project. Multiple methods can work, so public owners have the flexibility to choose which method fits best with their needs. Multiple prime is most applicable for small to medium-sized projects with low complexity and not required to be fast-tracked in terms of schedule. This method requires significant amount of management by the owner, which can be supported by using construction manager as advisor. You may reference the general conditions for multiple prime on OFCC's website, document number M140-007216. I will now describe the contractual framework of multiple prime. In this diagram, each box represents a different party. The lines drawn between them illustrate the legal contracts that are between the various parties involved in a project. At the top, the public owner, which may also fulfill the role of contracting authority, has a direct contract with the architect engineer, a commissioning agent when applicable, and with each of the prime contractors representing a different building trade involved with the project. The prime contractors are shown in the blue shaded area of the chart. Extending from those direct contracted entities are the subconsultants and subcontractors. The distinguishing characteristics of multiple prime delivery method includes the 100% completion of design development drawings from the architect engineer. The completed design documents are then publicly bid and awarded to the lowest responsive and responsible bidder for each trade package. Responsive means that all bid requirements were met, and responsible means that the bidder can do the work based on its capabilities and past performance. The bid packages required, but aren't limited to mechanical, electrical, plumbing, and general trades. The multiple primes involved all have direct contracts with the owner, but not with each other. This contracting relationship places the public owner between the trades and responsible for coordinating the work. For this reason, many public owners choose to use construction manager as advisor to better handle this responsibility and associated risk when implementing the multiple prime delivery method. Some broad recommendations to consider when using multiple prime include the use of independent cost estimating and constructability reviews of the design documents during the pre-construction phase. In addition, the owner is advised to seek scheduling coordination assistance during the construction phase. We will now cover the advantages and disadvantages of multiple prime delivery method. Advantages include the fact that prior to 2012, public owners were required to use multiple prime, and the owners may be more familiar with this delivery method over the alternate methods. As time passes, this advantage has decreased for most owners. Another advantage is that both the architect engineer and prime contractor is directly accountable to the owner. Because the design documents have to be fully developed prior to bidding, this adds clarity for all parties. Bidding tends to be more competitive from the increased prime bidding opportunities and lower bonding requirements. The more competitive public bidding can result in the initial lowest cost. A major disadvantage of multiple prime is that since the owner holds separate contracts with each prime contractor, there is a much higher risk associated with contractor claims and lack of coordination between the trades. Due to the requirement of 100% plans and specifications from the architect engineer, these projects have less opportunity to be accelerated and tend to be longer in duration. Another disadvantage is that owners have little flexibility in choosing both the prime or lead contractor and its subcontractors in comparison to other delivery methods. Implementing change during construction is complicated by coordinating the impact across multiple trades. Finally, this delivery method is the most adversarial in nature. Returning to the delivery method comparison diagram, the distinguishing characteristics of multiple prime has its advantages and disadvantages, and it places it in the lower left quadrant. Due to the owner's increased risk associated with this method, the project size, complexity, and speed of construction are all limited. Because the design documents must be fully developed, this gives owners more time during the pre-construction phase for changes. Each project delivery method has its own mix of advantages and disadvantages, representing different risk profiles for the public owner. It's important for the owners to understand their options and carefully select an appropriate delivery method that meets their needs. This concludes our training on the multiple prime delivery method. Other related training modules will describe the other 3 delivery methods in more detail. Thank you for attending this session. Hello, I'm Craig Weesey, Chief of Projects at the Ohio Facilities Construction Commission, and I will be covering the topic of general contracting delivery method. I will briefly describe the characteristics of the delivery method, as well as its advantages and disadvantages. General contracting is one of 4 available project delivery methods to public authorities in Ohio. The others are multiple prime, construction manager at risk, and design build. There are some similarities between these project delivery methods, as well as some key differentiators. Due to those differences, the particular delivery method may provide a better fit with the characteristics of a specific project. The diagram here illustrates the delivery methods in comparison to 4 broad project characteristics. At the center, each delivery method is represented by a circle, and its location to the other methods attempts to illustrate where that project delivery method fits in comparison to the project characteristics shown within each arrow. The project characteristics used for comparison purposes are project size, project complexity, schedule importance, and owner decisiveness. Each of these characteristics range from small to large or low to high. General contracting, abbreviated GC in the diagram, is shown in the lower right quadrant of the diagram. When comparing this delivery method using the same project characteristics, the GC method can more easily adapt to larger scale projects with more complexity than multiple prime. We will review the characteristics, advantages, and disadvantages to help explain why general contracting is shown here in the diagram. The overlapping of these circles illustrates that there isn't a one-size-fits-all type of solution when choosing the best delivery method for a project. Multiple methods can work, so project owners have the flexibility to choose which method fits their needs best. General contracting is applicable for any size projects regardless of complexity, scope, and budget. This method requires less management by the owner in comparison to multiple prime, which reduces risk. Similar to multiple prime, general contracting requires public bidding, which can be done by electronic means. See Administrative Code 153:1-8-01 for electronic bidding. You may also reference the general conditions for general contracting on OFCC's website, document number M160-007213. I will now describe the contractual framework of general contracting. In this diagram, each box represents a party. The lines between them illustrate the legal contracts that are between the various parties involved in a project. At the top, the public owner, which may also fulfill the role of contracting authority, has a direct contract with the architect engineer, a commissioning agent when applicable, and with a single general contractor, shown in blue for all of the various building trades involved with the project. Extending from those direct contracted entities are the subcontracts and subconsultants. The distinguishing characteristic of general contracting is that architect engineer completes 100% of the plans and specifications and publicly bids the work in a single package. This is also known as the design bid build process. The contract is awarded to the lowest responsive and responsible bidder. With all the trades being consolidated under the general contractor, the owner has a single point of responsibility and does not have to coordinate between the various trades, as required under multiple prime. Some broad recommendations to consider when using general contracting include the use of independent cost estimating and constructability reviews of the design documents during the pre-construction stage. We will now cover the advantages and disadvantages of general contracting. The largest advantage is the simple procurement method of a single contractor and a single point of responsibility to coordinate all of the work of the subcontractors. Another advantage is that both the architect and engineer and a general contractor is directly accountable to the owner. Because the design documents have to be fully developed prior to bidding, this adds clarity for all parties. A disadvantage of general contracting is that the owners have little flexibility in choosing both the general contractor and its subcontractors in comparison to other delivery methods. Since the general contractor has to supply a bond covering the entire scope of the project, there are fewer firms capable of doing the work when compared to multiple prime. Due to these requirements of 100% plans and specs from the architect, these projects have less opportunity to be accelerated and tend to be longer in duration. In addition, there is no input from the contractor during the design phase. Finally, this delivery method can be adversarial in nature. Returning to the delivery method comparison diagram, the distinguishing characteristics of general contracting with its advantages and disadvantages places it in the lower right quadrant. When comparing this delivery method using the same characteristics for the project, the GC method with a single point of responsibility for construction can more easily adapt to larger scale projects with more complexity than multiple prime. Due to the design, bid, build method, this linear progression also limits the speed of general contracting. Because the design documents must be fully developed, this does give the owners more time during the pre-construction phase for changes. Each project delivery method has its own mix of advantages and disadvantages, presenting different risk profiles for the public owner. It is important for owners to understand their options and carefully select an appropriate delivery method that meets their needs. This concludes our training on general contracting delivery method. Another related training modules will describe the 3 remaining delivery methods in more detail. Thank you for attending this session. Hello, I'm Craig Weesey, Chief of Projects at the Ohio Facilities Construction Commission. And I'll be covering the topic of design build delivery method. I will briefly describe the characteristics of the delivery method, as well as the advantages and disadvantages. Design build is one of 4 available project delivery methods to public authorities in Ohio. The others are multiple prime, general contracting, construction manager at risk. There are some similarities between these project delivery methods, as well as some key differentiators. Due to those differences, a particular delivery method may provide a better fit for the characteristics of a specific project. The diagram shown here illustrates the delivery methods in comparison to 4 broad project characteristics. At the center, each delivery method is represented by a circle, and its location to the other methods attempts to illustrate where that delivery method fits in comparison to the project characteristics shown within each arrow. Project characteristics used for comparison purposes are project size, project complexity, schedule importance, and owner decisiveness. Each of these characteristics range from small to large or low to high. Design build, abbreviated DB in the diagram, is shown in the upper left quadrant of the diagram. When comparing this delivery method using the same project characteristics, the design build method can adapt to projects of any size, but are ideal for schedule-driven projects that are led by decisive owners to make decisions timely. We will review the characteristics and advantages and disadvantages to help explain why design build is shown here in the diagram. The overlapping of these circles illustrates that there isn't a one-size-fits-all type of solution when choosing the best delivery method for a project. Multiple methods can work, so public owners have the flexibility to choose which method fits best for their needs. Design build, as I mentioned, is applicable for any size projects, regardless of complexity, scope, and budget. See Ohio Revised Code 153, as well as Administrative Code 153 for using design build. You may reference the general conditions for design build on OFCC's website, document number M180-1 20-007253. I will now describe the contractual framework for design build. In this diagram, each box represents a party. The lines drawn between them illustrate the legal contracts that are between the various parties involved in a project. In this method for contracting authority has a separate contract for a criteria architect engineer, while the architect engineer of record is within the design build team. This single point of responsibility of the design builder then holds subcontracts for all of the design disciplines and trade contractors. Other distinguishing characteristics of design build are similar to construction manager at risk, including best value, pre-construction services, design assist option for early involvement of specialty contractors, use of open book GMPs, and pre-qualification of first-tier subcontractors. Unlike other design build arrangements you might find in the private sector, public owners in Ohio are required to use a separate criteria architect engineer. The criteria AE documents the program of requirements and other important criteria of the owners that establishes the scope and quality of the project that the design builder must follow in executing the work. The criteria AE may assist in selecting the design build team and provide additional services through the construction phase. The owner may also fulfill this role themselves if they have a licensed architect or engineer on staff. Some broad requirements using design build include the use of qualification-based selection process for selecting the criteria AE and commissioning agents. Design build must be selected through a two-part best value selection process, including an RFQ and then an RFP. Design builder provides a GMP at time of selection or a design stage noted in the RFP. In addition, the first-tier subcontractors of the design builder are pre-qualified with the involvement of the owner. We'll now cover the advantages and disadvantages of design build delivery method. Advantages include a single point of responsibility for both design and construction, selection of the design builder based on qualifications and price, and early involvement during the pre-construction stage for contractor input. The design build team provides one or more open book GMPs or guaranteed maximum price proposals. These GMP packages can be based on drawings and specifications that are not fully developed, allowing the project schedule to be fast-tracked. There is no associated change orders if there are any errors and omissions from the architect or engineer of record. In addition, the pre-qualification of subcontractors provide owners more control of selecting subs. Finally, the criteria AE is procured separately by the owner, which can help ensure quality and compliance with the owner's intent contained in the criteria documents. A disadvantage of design build is that the owner has less control in selecting the design professional, since the architect engineer of record and builder propose together as a team. It is also hard to determine if best price has been achieved in comparison to public bidding, that is, within general contracting or multiple prime delivery methods. There's an increase in contingency for the design builder to assume risk, but at least it is transparent within an open book GMP. Design builders' overemphasis on price or schedule may impact quality. Like a general contractor and seem at risk, the design builder is required to supply a bond covering the entire scope of the project, and there are fewer firms capable of doing the work when compared to multiple prime. Owners are typically required to make quick decisions on fast projects and have less involvement with the details. There can also be disputes over scope of the work if the design criteria is not clear. Returning to the delivery method comparison diagram, the distinguishing characteristics of design build with its advantages and disadvantages places it at the upper left quadrant. When comparing this delivery method using the same project characteristics, the design build method with a single point of responsibility for design and construction can easily adapt to more complexity in projects. By not following a traditional design, bid, build, linear method, design build can execute the work through multiple GMP packages, allowing the schedule to be fast-tracked in comparison to general contracting. Each project delivery method has its mix of advantages and disadvantages, presenting different risk profiles to the public owner. It's important for the owner to understand their options and carefully select an appropriate delivery method that meets their needs. This concludes our training on design build delivery method. Other related training modules will describe the three remaining delivery methods in more detail. Thank you for attending this session. Hello, I'm Craig Weesey, Chief of Projects at the Ohio Facilities Construction Commission, and I'll be covering the topic of Construction Manager at Risk delivery method. I'll briefly describe the characteristics of the delivery method, as well as its advantages and disadvantages. Construction Manager at Risk is one of 4 available project delivery methods to public authorities in Ohio. The others are multiple prime, general contracting, and design build. There are some similarities between these delivery methods, as well as some key differentiators. Due to those differences, a particular delivery method may provide a better fit with the characteristics of a specific project. The diagram shown here illustrates the delivery methods in comparison to 4 broad project characteristics. At the center, each delivery method is represented by a circle, and its location to the other methods attempts to illustrate where that delivery method fits in comparison to the project characteristics shown within each arrow. The project characteristics used for comparison purposes are project size, project complexity, schedule importance, and owner decisiveness. Each of these characteristics range from small to large or low to high. Construction Manager at Risk, abbreviated CMR in the diagram, is shown in the upper right quadrant of the diagram. When comparing this delivery method using the same broad project characteristics, the CMR method is ideal for large-scale, complex, schedule-driven projects that are led by decisive owners. We will review the characteristics, advantages, and disadvantages to help explain why CMR at Risk is shown here in the diagram. The overlapping of these circles illustrates that there isn't a one-size-fits-all type of solution when choosing the best delivery method for a project. Multiple methods can work, so public owners have the flexibility to choose which method fits best with their needs. Construction Manager at Risk is applicable for any size project, regardless of complexity, scope, and budget. Ohio Revised Code Section 9.3 and 153 are applicable, as well as Administrative Code 153 for best value selection. You may reference the general conditions for Construction Manager at Risk on OFCC's website, document number M170-007223. I now will describe the contractual framework for Construction Manager at Risk. In this diagram, each box represents a party. The lines drawn between them illustrate the legal contracts that are between the various parties involved in a project. At the top, the public owner, which may also fulfill the role of contracting authority, has a direct contract with the architect engineer, a commissioning agent when applicable, and the construction manager at risk. Extending from those directly contracted entities are the subconsultants and subcontractors. The distinguishing characteristics of construction manager at risk is that the architect engineer that is procured separately does not have to fully complete the plans and specifications. The CMR is selected using a best value selection process, which includes elements of both qualifications and price. The CMR at risk can be selected early in the design phase and provide pre-construction services, such as estimating and constructability reviews. There is also the option to use Design Assist, which involves specialty trades early in the design process. Instead of publicly bidding, the CMR at risk provides a guaranteed maximum price, or GMP, which is open book, meaning pricing transparency for the owner. Another distinguishing characteristic is that all first-tier subcontractors are pre-qualified, allowing the public owner input on the criteria and who is allowed to bid. Like general contracting, the same at-risk entity is responsible for coordinating all of the work between the subcontractors. Some broad requirements using construction manager at risk include the use of qualification-based selection process for the Architect engineer and commissioning agents. Construction manager at risk must be selected through a two-part best value selection process, including a request for qualifications and then a request for proposals. The same at risk provides a guaranteed maximum price at the time of selection or design stage identified in the RFP. In addition, first-tier subcontractors of the same at risk team are pre-qualified with the involvement of the owner. We will now cover the advantages and disadvantages of construction manager at risk delivery method. Advantages include the selection of the CMR based on qualifications and price, and early involvement during the pre-construction stage for the contractor input. The CM at risk provides one or more open book guaranteed maximum price or GMP proposals. These GMP packages can be based on drawings and specifications that are not fully complete, allowing the project's schedule to be fast-tracked. Like general contracting, the CM at risk reduces owner's risk due to a single point of responsibility for coordinating construction. In addition, the pre-qualification of subcontractors provide owners more control of selecting subs. Finally, the architect engineer is procured separately by the owner, allowing owners more control in selecting the design professional in comparison to design build method, which proposes as a team. A disadvantage of CM at risk is that it's hard to determine if best price has been achieved in comparison to public bidding in general contracting and multiple prime delivery methods. There is an increase in contingency for the CM to assume risk, but at least it is transparent in the open book GMPs. Like a general contractor, construction manager at risk is required to supply a bond covering the entire scope of the project, and there are fewer firms capable of doing the work when compared to multiple prime. There can be disputes over scope of work if the GMP is not clear. Finally, the relationship between the CM at risk and the owner may change after the start of construction due to the transfer of risk. Returning to the delivery method comparison diagram, the distinguishing characteristics of construction manager at risk, with its advantages and disadvantages, places it in the upper right quadrant. When comparing this delivery method using the same project characteristics, the CMR method, with a single point of responsibility for construction, can more easily adapt to larger scale projects with more complexity than multiple prime. By not following a traditional design, bid, build linear method, CM at risk can execute the work through multiple GMP packages, allowing the schedule to be fast-tracked in comparison to general contracting. Each delivery method has its own mix of advantages and disadvantages, presenting different risk profiles for the public owner. It's important for owners to understand their options and carefully select an appropriate method that meets their needs. This concludes our training on construction manager at risk delivery method. Other related training modules will describe the 3 remaining delivery methods in more detail. Thank you for attending this session.
Thank you for attending this session. Please be sure to register and attend all other sessions to complete this training. Keep the session's completion certificate until you have completed the entire training.